All right, we're now into the calculator multiple choice section. And the first one is a problem that almost every student asks me at some point, and so I'm just going to go over it and show you how I do it. The fact is that it's not entirely doable on your calculator. You need to actually think some. So what I like to do here is take this polynomial, and they're telling me k is positive, which is helpful, and they want to know the area of the region between the x-axis and the graph. And I have a hard time doing this without visualizing that region. So what I like to do, and I'm going to go work down at the bottom here, is say that f of x equals x squared times k minus x. So I just factored out an x squared. So now I'm able to actually graph this guy. So I have a double zero at the origin, which is right here. And then because k is positive, I have another 0 over here at k. And because the leading coefficient up here of the x cubed, the highest degree, is negative, that means I have opposite end behavior. So this is what my graph is going to look like. I think that's really helpful because it tells me that this is the region that I'm looking to find the area of, and it helps me set up an integral. And the integral is going to be the integral from 0 to k of our function, kx squared minus x cubed dx. And this is where the calculator comes in. You can do this by hand because it's a polynomial, but let's go ahead and practice on our calculator. So what we're going to do is let's use the alpha key to plug in k, and then I have k x squared minus x cubed, enter. And then I'm going to integrate. So I go to F3, choice 2 is integrate, go grab my function, bring it into the line, and then I want to integrate with respect to x. So I hit comma x, comma, and then my lower limit of integration is 0, then comma k for my upper limit of integration. And I hit enter, and I'll find out that my answer actually involves k. So I have here, oh, isn't that interesting? You know what I didn't do? I'm going to have to, this is actually a good teaching moment. Didn't like the fact that I have effectively an invalid implied multiply. So I need a multiplication symbol between the k and the x squared. So let me go do this again, and I'll show you that it will work this time. So I hit F3, integrate. Now I'll go grab my new function with the valid implied multiply. Comma x, comma 0, comma k. And then it simplifies all the way to k to the 4th over 12, and my answer will be D. All right, for number 2, you can do this through u substitution. And I'll just point out that if you do u substitution, your u is tangent x, and your du is secant squared x dx. So you're just integrating u squared du, which integrates to u cubed over 3 plus c. So it's tangent cubed over 3 plus c. But I'm going to actually just show you on your calculator just to make sure we can all do it on our calculators. So if I hit integrate, and then I need secant squared, and to get that I have to do 1 divided by, open parentheses, second cosine of x, close parentheses twice, then square it. And then I'm multiplying by, open parentheses, second tangent x, close parentheses twice, then square it, comma x. So I'm integrating 1 over cosine squared times tangent squared, and I do get the tangent cubed over 3. The calculator's not giving me my plus c. I have to know to add that in. And then the last problem on this page says, it's actually a fundamental theorem of calculus, part 2 problem, says that the motion of the particle is given by s, and then this is a t value and that is a u value. So to get from s to v, what you have to do is differentiate by plugging the t in for the u. So my v velocity is going to be 1 over t squared plus 1. And then they want my acceleration. So acceleration, I can get this again by hand. So I can do t squared plus 1 to the negative 2 and bring down the degree of negative 1 times the derivative of t squared plus 1, which is 2t. That is my second derivative, and I plug in 1, and I'm going to end up with negative 2 over 2 squared, which is 4. So my answer should be A. But when I get to this velocity function right here, I can go ahead and differentiate that on my calculator just to confirm. So if I use 1 divided by, open paren, t squared plus 1, close paren, and then let's go to differentiate, enter, comma t, close paren, there's my derivative, and let's evaluate it such that t equals 1 just to make sure we got it right, and we did.